Welcome back to TAFE New South Wales and Riverina Institute, the effects of electric current. So this practical session we're going to focus on the heating effect. What happens when we pass an electric current through a circuit? We're going to prove that it produces a heat. The practical exercise I've got already connected here, I've got the good old power supply through a switch into an ammeter, into a wire wound resistor of 6 ohms and back through to home. To prove this, that as I increase the voltage, because the resistor is not changing value, so as we know from Ohm's law, as I increase the voltage on the power supply, the current, assuming resistance stays okay, stays the same, the current will increase. And what will happen is the resistor will heat up. So what I've got here is a thermometer. Not sure now that I've got a little laser thermometer. So the red dot on the resistor, I can see that the resistor is sitting at 25 degrees, pretty much ambient temperature of the room, which is around 24 degrees, so about a degree hotter. I'll turn on the power supply. Power supply is approximately 5 volts. I'll turn the switch on and we've got a current flowing through the circuit of 0.8 of an amp. And as you can see there, the resistor, might be a hard screen grab, but if we can probably get the resistor and the thermometer, I've got around 26 degrees, 27 degrees, and it's slowly heating up. So the current produced through the circuit has a heating effect on this resistor. 27 degrees. Let me increase the voltage. I'll go up to 10 volts now, and therefore the current must increase, because V is equal to I times R. So I've increased the voltage, resistance stays the same, the current's obviously going to increase, directly proportional to. And as you can see here, I'll just flip this meter back on, sorry about that. We've got a current of 1.6 amps now, and the temperature has jumped dramatically up to around 50 degrees. Look at that, 56, 57 degrees Celsius. So we start off at 24, so it's almost double. So the heating, the actual temperature of that resistor is increased almost double, with a double of the voltage. And I'll go up to 15 volts. And I'm up to 2.5 amps. And I'll check the temperature again. And now I've got over 100. I've got to put it on there. And the resistor, 80 degrees, is starting to smoke. So I'll turn that off. Clearly we don't want to burn the resistor out. But 90 degrees, depending whereabouts on that resistor I'm on, it's slowly going down now. So we've proven the fact that an electric current flows, we've got a heating effect. This heating effect, obviously this is a crude example of the heating effect. We've got a resistor, and obviously I was to touch the resistor, I'd have heat on that. This effect of electric current we use obviously in stovetops, in ovens, also electric kettles, where the resistive element, or the element, in this particular resistor, but an element goes inside an electric jug with water in it. We turn the jug on and the element gets hot and boils the water. So it's used quite a lot out there in the workplace. And thus ends the conclusion of this practical exercise.